All right. I think we got it now.
Yeah. Welcome to our workshop, finally, Interactive Data Visualizations with Maki. I'm Simon, and I'm doing this together with Julius Krumbiegel. Yeah. What are we talking about today? First of all, we want to give a little overview about what is Maki for everyone to be on the same page. Then we have a little announcement section that we want to talk about, and then to talk about what everyone is interested the most. It's time to first plot and how to create a system image. So we want to start with that. Then Julius will give a little overview of how to get started with the docs and look things up. And after that, we continue giving an overview of our backends and showing some of the Maki building blocks and going one level up, showing the layouting system, which is built out of these blocks, and a bit about sizes and units. And then I'll give a recipe example with some interactions, and Julius will show us a nice interactive app example. All right, what is Maki? Obviously a plotting framework. It has extensive 2D and 3D capabilities and is made for interactive workflows. It's hackable, extensible, and fast. At least that was always the goal. And it's 100% in Julia. Some people have a bit about an argument about that, but I think the core of Maki is pretty much 100% Julia. The backends a bit less so, but to some extent it's questionable, how far you really can go to draw a pixel on a screen in Julia. But I think it's in the parts where it matters, it's Julia and hackable. And what was really important to me is that the core building blocks are like a backend independent drawing library, because with other plotting libraries, I made the experience that you can do super nice plots with a high level API, but then you just want to add a drawn error or something like that. And then suddenly it becomes really hard to do that in that high level API. So I wanted to do it the other way around, that you add all these high level plotting APIs on top of a more simpler API. Yeah, and then you have multiple backends with different strength. We will show that. And Julius created an amazing layouting system for creative and polished figures. Yeah. Now, we really want to thank our sponsors, Pumas AI and Beacon Biosignals, who spent some money for this workshop to help us work on it. Which brings us to the whole funding story of Maki, which I want to talk about. First, a bit of history. So the MIT Julia group paid me for several years to work almost full-time on Maki and all the ecosystem around it and GPU computing, which was really amazing because otherwise writing such a large framework from scratch would have been impossible. And since then, Maki has been mainly developed in our free time or on the side of some commercial projects where it was like 10 to 20% were allowed to like fix bugs or implement specific features that were needed for some commercial projects, or the classic besides university. I think that's what Julius did most of the time during the PhD. And I really want to give a shout out here to Julius, because when I started accepting non-Maki jobs after the MIT time, I really didn't have that much time anymore for Maki development. And that's when Julius just popped up and did so much amazing work on Maki, polishing the documentation and creating all the high-level APIs that make plotting really workable. So probably you could say Julius saved Maki in that regard. And that brings us to the present. I actually quit my job to concentrate on working more on Maki. Julius works for Pumas now, which focus on Maki projects. And we started tracking our time a bit to see what does it actually take to maintain Maki. And we came to like 1 to 3 days for each one of us. So like in an intense week, that's maybe 6 days of full development time just to keep the project running. And if we are not doing that, it seems like that 10 to 20 PRs are piling up without review each week. It becomes less the longer it goes, because then people just stop working on it. But if we come back, people are really happy to actually contribute when we actually review stuff and merge stuff. And here, big thanks to Petro, Ferric, and Anshul, who have been starting to do more and more review work and really created amazing features. And of course, all the other contributors that we can't list here. Yeah, but this brings us to a large step. We want to join NumFocus to get some more stable funding for all this maintenance work, and maybe even put more time into actually reaching out to people and polishing Maki's appearance, and write blog posts and stuff like that to actually really actively search for developers and users, because right now it's kind of dreadful to get more users because it means more work in our free time. But if we would actually have more time, it would be amazing to see Maki grow even further. And that will mean gathering funds from companies and professional Maki users who actually use it in their commercial day-to-day enterprise. And I think it would be just fair to really get Maki developed there. And when we join NumFolks, we hope also for a deeper integration into the whole scientific computing world. Maybe there will be a Python wrapper or something like that, but we shall see. But I think, yeah, the Julia community really deserves a plotting library with active, well-funded development on it. So I hope Maki can become that. And of course, we will get more community events like MakiCon if we have more time for this. We are actually currently planning with Lazaro Alonso to host our next MakiCon at Max Planck Institute. So big shout out to that, and I really hope this will happen. I think it will be amazing to have these kind of events more regularly and more well organized in the future.
There was just a brief question on the pigeonhole, what joining NumFocus means. Can you maybe say something about that again?
Oh, yeah. That means that, well, first of all, we get more visibility, I guess, in the whole community with the big NumFocus logo, and they do some outreach and newsletters and stuff like that. And also they organize funds, so like companies can donate money with all the tax exemptions, etc., and they will make sure this all is legally correct, which we wouldn't be able to do right now immediately ourselves. So yeah, it will also be the way to actually accept funds in a legal way, a sound way. Okay. Yeah, so that's also why we want to move to Maki.org. Originally, Maki has been grown in the Julia Plots GitHub org, which was great. And I've also been the admin there with the goal that I oversee a larger portion of the Julia Plots ecosystem. But that was a bit unrealistic because I never really had even enough time to work on Maki, on all the things I want to. So committing time to plots.jl or other libraries in Julia Plots didn't really happen. So I think moving to Maki.org makes a lot of sense, also to just have all the Maki developers only access to Maki and not to plots.jl and all these little things. Also, then we can have our own website and stuff like that more easily with the GitHub integration, and maybe even accept funds for the GitHub donations in a more Maki-focused way. The website so far, only blog.maki.org is online. I think we will do the redirect for the docs to docs.maki.org very soon. And the other websites are just planned right now. So Maki.org will give an overview over the whole ecosystem. Beautiful Maki will be the website that Lazaro created, and Awesome the Maki will just give an overview over all the awesome libraries created with Maki or for Maki. And yeah, I hope this will help concentrate on developing Maki's ecosystem. And while at it, we also wanted to move more of the chat conversation to Discord. We thought a bit about it, what would be a good platform. We experimented with Telegram, which didn't have any developer-focused features, so that didn't work out too well. Slack doesn't have a history, which is very annoying when discussing something like MakiCon or VisCon, stuff like that, because then everything is just gone. Zulip is great too, but I've never really got fond of it. Every time I open it, it just doesn't make that much sense to me. And Discord seems really great. We have our own Maki server with our own channels. It has thread support, a bit of syntax highlighting, and really easy ways to just like work together and have voice chats and stuff like that. So I hope we're moving a few things to Discord. I don't think we will force anyone to to go there, but I want to move the core Maki groups focus to do the communication via Discord in the future. Yes, this already brings us to the big picture of what is Maki and what are the basic building blocks. So Maki, the very core building blocks are just the backend primitives that each backend needs to be able to draw, which is currently mesh, line, scatter, volume, and text. There are a few more like line segments and surface and stuff like that, but they're more of an optimization. Like surface could be done with just a mesh plot, and that's actually how it's done in WebGL Maki, for example. So these are more the real core one. Even scatter could be removed from here because it's also just an optimization of just having a mesh with some kind of cutout or something like that. But yeah, these are kind of the current primitives. And if you're creating a recipe, it's just a matter of combining these primitives, and they're collected in combined plot, which just means combining them. And it's recursive, so you can call recipes in recipes, which then will add a combined plot to the other combined plot. And that's how you create more complex visualizations with Maki. And all of this is added to the scene, which is a bit like a window abstraction with a scene graph. And that all happens in Makie.jl, is completely backend independent, and is basically just a description of what needs to be drawn. And then the backends come in and they create the actual pixel representation, or in case of Maki, also a vector representation. So just going through them, WebGL Maki is for the use case if you want to show a plot in a browser, and then it uses the browser's WebGL API to actually draw stuff on the screen. Maki is more for publication-ready graphics, and its output format is SVG or PDF, so vector graphics, but also since Cairo just offers it, you can create PNGs with it. It's not interactive because SVGs or PDFs aren't really interactive, but there's actually nothing stopping us to just create a GTK like window where you use Maki inside to redraw every time something changes. But since that's the use case for GeoMaki, which most people can just use instead, where you have a native window with all the interactions and all the interactivity, this hasn't really been done yet. So Maki is pretty much for static plots. And then there's a new backend. It's called RPR Maki, which comes from Radeon ProRender, which is a ray tracing renderer from AMD. Even though it's from AMD, it's cross-platform because it's written in OpenCL, so it works also with NVIDIA. And it actually renders the pixel to screen by ray tracing, which enables you to create stunning graphics. But it's pretty experimental. I don't know, I tried it out again some time ago and I got a seg fault, so it needs more polish. And as you can see, like the background is gray a bit. That's just because it needs a more complex light setup to create something good looking. So it's a bit different from the other backends. And Maki, you can see also that the texture is a bit fuzzy. That's because 3D rendering for Cairo is a bit more complicated. So we pretty much had to hack it in, and then you get these kind of differences between the backends. But the goal is to make them as similar as possible, if possible, pixel perfect output and matching between the backends. But that requires more work to actually achieve that. Yeah, so I already mentioned the scene where everything gets collected and added to. Here's from the docs. There's a scene tutorial which explains how the scene works in more depth, but just a quick look at it to get an idea of what this contains. It's pretty much just holding a local theme that gets applied to all the plot objects in that scene. So that's where the theming comes from. And the theme can get set globally, but that just means it gets added to every scene you create. That's where it ends up in. Also manages the camera and projection and transformation matrices. So that's where all the magic happens if you move around in a plot in GeoMaki, for example, interactively, then all these camera and projection matrices are transformed inside the scene. And it defines the window bounds, and for subscenes, it's also allows you to just inset them and make a smaller window inside a smaller window inside a smaller window. That's what Julius has been using for the whole layouting system to make that happen. So that's also why the layouting system is outside of all these more core abstractions. And yeah, the scene holds a reference to all window events. So that's where you need to go if you actually want to create interactivity from window events, like the mouse events and stuff like that. Yeah, that's it from our slides. And I guess that brings us to the system image and how to build it. And that's actually very easy. I did a lot of work on compile time latency for Maki and with a community grant from NumFocus. And that also meant adding a lot of precompile statements to Maki, which is actually great news for creating system image, because one of the hard parts is usually that you need to create a file that traces what you want to run, and from there actually creates the system image with all the functions compiled. Because if you don't do that, no function will get precompiled, and that means only the using time will be reduced, but not like the time to first plot. But now that we added quite a lot of precompiles to Maki, creating a system image is as easy as just running this command. And then if we actually oh, yeah, that's from the from the other VS Code session.
Yeah, maybe let's mention again that
Here we go.
the files that you're looking at are in this repository that you can clone to, like some of the stuff that we will show, we will do like while we are telling it, we'll do it on the fly, but some of it is written down, and all those files are in the JuliaCon repository that we showed at the beginning. And I posted the link into the chat as well. I can post it again, just so everybody has a chance to see it.
Yeah.
Ah, yeah.
All right. So as you can see, this brings down the time to first plot significantly. Actually, it was a bit faster than this, 4.8 seconds before. I guess it's because all of the streaming that happens now. It's a bit slower, but...
And this includes running Julia with the big sys image, so...
Yeah. Yeah. I think that's a great improvement. And it's not perfect yet. I think we could easily get under 1 second if we add more precompiles and more exhaustively and remove more code invalidation. But I think this is a pretty good start. Yeah, you can also do the same with VS Code, which kind of automatically builds your current active project. You just need to search for the command run build task and then build custom system image, which does all of this very easily and automatically. Takes around 5 minutes on a faster PC. I've never tried it on a slow one, so I don't know. Might be quite a bit more. I won't run this now, but I already did that on the other VS Code session to actually get these speed ups. And what's important for this as well is you need to actually go to the Julia settings, plugin settings, and activate that it uses the system image that you created with the build task. I don't know, it's somewhere here.
You can search at the top.
I think I'm almost there.
Yeah, and someone on the Pigeonhole.
Use custom system image.
Yeah, someone on the Pigeonhole asked if you can also load those into a Pluto notebook. And yes, so I mean, Pluto runs in a Julia process, right? So you can, however you load your Julia process, you will run Pluto inside that. So if you run the Julia process with the sys image, then you have it in Pluto as well.
Yeah. Yeah, so that should be easily possible. Yeah, we will put a bit more work into this, I think, going forward. But yeah, that's the current state. And I think once the NumFocus grant is finished, the time to first plot should be 70% less. So that's hopefully also a good improvement for everyone. All right. Back to the agenda. I guess we're now for Julius and layouts.
More like showing the docs, right? Yeah. Give me a second. Yeah, I just wanted to say before we dive into the weeds, that the best way to get all the information on how Maki works and so on is by visiting the docs. And I just wanted to show like the main pages because maybe it's a bit much on the first try. Give me a second. So now this whole thing will. Okay. Yeah, infinite streams. Okay, so yeah, the our docs page is called Maki.juliaplots.org, and the things that are most important at first, I would say, are the tutorials if you are getting started. So we have one tutorial that shows like the basic primitives that you can use in Maki. So how like the basic objects like the axes, the plot objects, and so on, how those work. I would recommend starting with that. I wrote one tutorial on the advanced layout functionality that is also pretty good. If you want deeper insight into the scenes, but Simon will talk about this more, then the scene tutorial is also good. This one is pretty specific, and you will probably only need that later once you've started getting more complex with your plotting. And then there is the examples page, and we've split that up into blocks and widgets and plotting functions. And if you want to know about the basic plotting functions, so what Simon mentioned, or also called recipes, those are here. So you can see there's an overview page with a lot of example images for each type. And as Simon said, all of those plotting recipes build on some of the primitives that he mentioned, like the lines or scatter or so on. So for example, AB lines with is a recipe to draw a linear regression kind of line through the scene. That's obviously based on the line primitive. Arrows is line segments plus scatter. Band is a polygon, which itself is really a wireframe plus a mesh, and so on. And all of these, have a couple of examples that should get you going relatively quickly. And that will be probably the thing you visit most in the docs. And the other part of the example page is the blocks and widgets page. And these objects are not just plotting functions like the recipes. So there's a bit of a semantic distinction. I mean, in the end, everything is kind of just plotting functions bundled together, yes, but all the blocks, as they're called now since a couple versions, they have the ability to take part in the layout functionality, right? So the normal plotting objects like a scatter or a text or whatever, they wouldn't know how to behave in a layout. And for that, we have these higher, like these meta objects. For example, the most basic one is the axis, which you will use for almost all your 2D plotting. And you can see on this overview page, there's like tons of pictures there. And I will show a couple of these later. And also notice that all of these, I would say the focus of these two sections is a little bit different, because the examples, I mean, it's called examples for lack of a better name, but if you look at like the list of stuff that's written in this axis chapter, like all this, there's a lot of information here which goes like beyond just examples, and also explanation how things work and so on. So it really pays off to just like scroll through this once in a while to get a feel for what all the different options are, because I get a lot of questions about how can you add, I don't know, second axis, how can you set a subtitle and so on. So I think a lot of this clears itself up if you just have a look at this once. So you kind of get an idea of what features there are and so on. And for everything else, you can of course ask like on the Discord channel, the new one, or I actually prefer getting usage questions on the discourse. So not Discord, but discourse, because it is kind of a service to the community if you ask your question in a venue that makes the answer searchable, and also that it will persist there, because I personally, and Simon also, like we asked, we respond to a lot of questions on Slack, but anybody who used Slack, the Julia Slack, will know that the stuff that you write there disappears after a while. And basically that's wasted effort. So I like going to the discourse page to ask any kind of like question that you can't find in the docs. And usually we transfer stuff that should go into the docs there later. And this way, people coming after you having the same questions can go there. And yeah, there are already a lot of questions there. There's also some activity on Stack Overflow, but I personally don't frequent that site. So if you want answers from me, probably should go to the discourse. Yeah, all right. So yeah, that's the basic thing I wanted to show in the docs. The rest, so of course there's like an API overview page, but that's really a ton of information, and you should probably just go there if you look for one specific function, but you can get the same information because those are just the doc strings printed out for all the objects that we have, right? So you can get the same thing by just going into the normal REPL help mode in Julia. There's more here for like completeness sake. And then there's the news page, which if you followed Maki for a bit, I think in recent times we haven't been that breaking in our releases, but once in a while we reach a point where an old design pattern just doesn't work that well anymore and we want to make a change. And because we have the luxury of not having like a huge user base yet, which would scream if we made any changes. So once in a while we do introduce breaking versions, but usually the way to update is really simple. So the first thing you could do if you find like a new error and you think like some behavior changed, you might just look on the news page, and usually we tag these if we're diligent with like a breaking notice. But yeah, if you have a look through here, you will see that most of them are actually pretty minor, and we haven't reworked like the deep basics in a while. So because I guess that some people might be worried about like, if I use this library, will my code be obsolete soon and so on. And I don't think the basics of it will change that much. So like we want to do backend work in the future, but we try to keep the Surface API mostly the same because I think that works relatively well right now. All right, and then the documentation section. This gives you like deeper explanations of certain topics. So yeah, have a look at that at your leisure. But I would say the tutorials and the examples are like the thing to spend most time on. All right. With that, I think we can go to the next thing. Now we have the infinite screens again. Let me just remove this for me. All right. And let me just check if there's any specific questions, because I can't see while I share the screen. Am I on a different page? I can't see everything at the same time. Right. So, right. Is there any Maki cheat sheet available? No, not in this PDF form that you might have seen for different projects. But if anybody's motivated to do it, it would probably be pretty great. I think Lazaro might have done something similar, as someone says here, 100 Days of Maki, or like Beautiful Maki. That's a really great resource also for more examples, which you could check out. And yeah, the other question with like the tight layout, I'll get to that later. Right, so let's see in the agenda. Yeah, we wanted to talk about the different backends and Maki's building blocks. And with that, I'll give back to Simon.
So backends and building blocks, you already did that. So I guess now it's layouts and sizes or units. We skipped the docs when I went to talk about backends and Maki building blocks.
Sorry, did you ask me something? I'm trying to get rid of this banner. So you just made me aware of. Not sure.
Yeah, so I think the next one is layouts and sizes and units.
Okay. Yeah, then give me a second.
Sure.
Just to. just to get rid of the, or can you try getting rid of this? Can you display? I don't know who put it there. There must be some options over here. All right, but in the meantime, I can go to.
There. Is it gone?
Yeah, it's gone. That's good. Right. But yeah, I think before, yeah, okay. I thought Maki's building blocks was also including like the figure and X and stuff. I'll show that first because otherwise the rest doesn't really make sense, I think. Okay, so let me go here. I'll add this to the stream again. Okay, I'll just restart this session. So, okay, this is in VS Code now. This should go away. I hope. Yeah, I'll make the font a bit bigger. Is that easy to see? I need to check with the questions page. Yeah, it looks okay-ish for me. Okay. All right. So I think I want to just show off some of the basic building blocks that you need when you draw something with Maki, and then we'll go from there. So this will be pretty much on the fly because, okay, let's first. I mean, you can follow along with this in your REPL if you kind of have the same versions. It should all be the same. Right, so let's see. Yeah. Okay, the first thing you do is you import some backend. For example, in this case, Maki. Maki only does static plots, so no window will pop up. But I'm in VS Code here, and VS Code has this plotting pane, which is empty right now. But it's set up such that if you make like a plot, or maybe I'll just do like a complete plot first. So some stuff will appear. I'll just do like, I don't know, lines from 1 to 10. So this should hopefully show up. Oh, okay. I think the other backend was still activated. So that's some of the interesting thing with, yeah, okay. So what happened there was that through the system image, Maki was already activated. And now I changed it to Maki. So this activate command changes the currently active backend. Okay, so like the anatomy of one of the plots in Maki, what's happening here. So you can see in the plotting pane that now we have this line plot from 1 to 10, as I specified. And yeah, there are like different options in Maki how you can run plots. They're kind of similar to some of Plot.jl's capabilities. So especially that you have different signatures. So for example, you can plot a function over some interval, or you can choose the interval with the dot dot function, and then it will like try to choose a better resolution for whatever function you have there. And I wanted to show like what the basic building blocks of this are before I go like to the layout stuff. So some of you might already know about this and some not. So I think going at it more basically might be beneficial. So the base object, as Simon said, the base object actually is called the scene. So I can make a scene and it's white, so you don't see anything here, but I think I can just go background color as red. Yeah, so now we made a red scene, which appeared here. And the scene itself is important to understand if you want to hack on Maki plots, but it's not the most user-facing object. So everything else that I'm going to show you is based on this, like a scene containing plots. But I'm just telling you this so you get an idea of how these objects all stack on top of each other. And because I think it's like a benefit of the package that if you have some idea of the underlying logic, that you can go in and change things. if the behavior is not exactly what you need for a certain situation. Right. So yeah, the basic thing is like the scene. And what we usually work with when we plot something is not the scene, but the figure. And again, if I execute this command, then a white figure appears, so you don't see anything. But I can do kind of the same thing again, make like a tomato colored figure. And I want to show something about this figure. So if I assign it to some variable and I do like f, what is actually in there, you can see that there's a scene and a layout. And so the scene, if I show that, then the exact same plot appears, because as I said, so the scene is the underlying thing and the figure is just a container which helps position and keep track of objects that we add to it. So for example, like axes. And so the next step that you would do if you build like a figure from scratch is you would add some object to it. And I showed you on the docs page before what these are, and one of them is called axis. And we have the syntax in Maki, which where you specify a location in a figure by kind of indexing into it. So for example, first row, first column, that is like a position in the layout. If I execute just this, then you get an object called a grid position, and these objects like axis and so on, they know what to do with this grid position, like to put themselves there if you add them. So for those who don't know, if you do like this double # thing in VS Code, then you can run like the block of text between those with option return. So I just do that here for convenience, so I don't have to mark it all and run it like that. Right. So if I run this code, then you get this axis, which fills the whole figure kind of. And there are like attributes that you can set on these objects. For example, like my axis as a title, and then you get that showing. Kind of self-explanatory, I think. And again, this axis object, and I want to also show that if I say like x as axis, then x itself has, like every block, it has something called a block scene, which is the scene which contains all the plotting objects and the scenes, the sub-scenes that make up this axis. And you see that when I executed this, I mean, you didn't see anything because it was the same plot, but here like 14 of 14 plots. And if I run this again, now it's 15. So basically the X itself, the axis has its own scene keeping track of, for example, like this stuff here, the axis decorations. So for example, this is one text plot and these three are one text plot. Then there's lines for the grid and so on. So because we said Maki is like hackable and tweakable, so you can always go in and look at what these plot objects are. So for example, I think if I do this x plot scene block scene.plots, then you can see all the stuff that is already in there, like the text plots, the line segments, and so on. And you can, in theory, go in on any of these and change stuff. So I think, I mean, I'll just try this randomly. So if I take like the second plot in there, which is like a line segments thing, and I should be able to set the color of that to red. And so if I show the figure now, yeah, okay, you can see that this was one of the grid lines, which is red now. So that's, I think that is useful to know, like that the axis itself is just like a wrapper around a scene, and the scene contains plots and so on, and you can go in and change everything you want about that. And so what happens if I showed you this lines command, right? So lines is a function that makes a lines, like the capitalized one is the capitalized one is like the plot type, and the not capitalized function is the one that you can usually use to plot stuff. So you interface mostly with this function, but sometimes you also need the type when you do like recipes, or if you have ever used algebra of graphics, it also wants you to pass this. But yeah, these always go together, like the title case one and the other one. So if I run the lines function, and again, I'll do like 1, 2, 10, keep like doing the same plots. Then you get this plot, and as you know, we need like a figure, we need an axis, and inside the axis there are plot objects. So the object that's being returned from a call like that is called figure axis plot. And yeah, that might be like confusing to some, but this is actually just like a 3-element collection type, which just says that, I mean, if you want to plot a lines function, you will usually not want to plot it into some empty scene, which doesn't have any decorations, any axis markers, and so on. It used to be a little bit like that some years ago, but in the meantime, it changed, and now every like common plot contains like this figure, which then keeps track of the other stuff. So we want this call here to actually show something, right? So we overloaded this return type figure axis plot so that it actually shows the underlying scene. And if you plot something like this, you can split it up into the figure, the axis, and the plot, which in this case I'll just call L for lines. So if you run that, like nothing, like it's still the same output, but we can check now that type of F is figure, and the type of X is axis, and the type of L is this lines plot with a certain signature. So yeah, that's like the basics of how you plot. This is just like a convenience syntax, right? You could kind of do the same by, and like in the examples, I sometimes go this way, sometimes go the other way. It's all kind of ad hoc. You can go like this, make the axis, and then you use the different syntax, which has this exclamation point. If you have used Julia before, you'll know that this is like usually a mutating operation. So you change some object and you can pass the axis, and then you can do the same thing, like 1 to 10 and sign, and then pass that back. And if we run that, yeah, exactly the same output, not surprisingly. Or maybe I'll just do a cosine so you can see something changed. Right. So those are like the basic operations. And of course, there are other objects that you can use. So for example, and this brings us already to the layout functionality. And we wanted in this workshop to go a bit like deeper than just the basics, or at least give you an understanding of these parts so that you can hack around on it yourself and try to find out how all these different parts play together and so on. So I can show you something basic, like I can just add a color by to this figure. And the same vein that I said, like first row, first column for this axis, I can go and say like first row and second column for the color bar. And this will just be like a freestanding color bar because I didn't tell it to reflect any kind of plot that's happening here. So I think that's also I would say like a philosophy point in Maki. So maybe in other plotting packages, and maybe the best example is probably just plots, Plots.jl, because in plots, if you do any kind of line plot that has changing color, I think it will automatically give you a color bar on the side, right? And in a lot of cases, that is what you want. And it's nice convenience. And in Maki, you usually have to build that yourself in 2 steps. But like in my experience, people doing more complex, creative kind of figures, they sometimes want a color bar that doesn't really refer to like one specific plot object, or it might cover multiple, or maybe they just want to show a color bar for any reason. So all of these are really like separate objects, which can be told about each other. But as you see, I can just do like a random freestanding color bar in this scene. But usually these things have constructors such that if you do a line and let's say the color of that, okay, I'll do 1 to 10. So we actually know that there's 10 elements, and then I can also do, I think, color from 1 to 10. It should vary now. And then if I pass L as the first argument, or the second after the position to color bar, then it should, yeah, and you can see now that the color bar reflects what the what the line plot was doing. So that's usually how it goes. But you can kind of fake the same thing by just saying, I think it's like limits 1 to 10. Like you couldn't see the difference in this plot, right? Now the color bar doesn't know anything about the lines plot, but it still matches what's going on. And I think that's like a common pattern, that sometimes you do need this manual control and you do need to tell the objects exactly like what you want them to do. And you're supposed to be able to do that in Maki. Right, so let's continue maybe by just putting random different objects into the figure, just so you can see some more of the syntax options. So one thing would be like a heat map that you can do, and there's a different syntax where you place the position in the figure as the first argument to heat map. Then you don't use the mutating function because it will create a new axis. So let's say second row and across both, like all the columns that we have here, and I can just do like a random heat map like this. And maybe let's say column map is like heat. And then you get like, as you can see, like the heat map now spans the first 2 columns, kind of ends here on the side where the inner part of the color bar ends. And on the left side, it's aligned with this axis right here. And then for good measure, like we could do a bar plot that goes from like goes along all the rows, but maybe the 3rd column, so beyond what is already there. And we just do random values again. So like this. And then, yeah, as you can see now, there's a bar plot on the right side spanning those rows and columns. And this is how you can build up like a an interactive, or like iteratively, I mean, not interactive, as said, Maki is not interactive, but that's how you can build up a scene. And I wanted to talk a little bit more about like how these layouts work and how you can tweak them to your liking. And now that you've seen like some basic objects here, I think I had this over here in the layouts script. Right. So yeah, you can open that on your computers as well if you want, or just follow it here. And for this, I can also use Maki again, just so I can show you some stuff in an interactively changing window. So using Maki is kind of like unneeded, I guess, because of the system image that has it baked in, like on my side. But on your side, if you don't have a system image, you would of course need to run that, and it would need some like time to first plot, which you don't really see here because of the nice system image. Then I do something which is like a useful thing if you have a smaller screen. I set there's a function called set window config, and you can say float true, and then the window that I show will just always be visible even if I go back to VS Code, because otherwise it's annoying to go back and forth on that. So hopefully, yeah, because it was already visible in the background. So yeah, this worked now. I just restarted it. So let's say that is like a window, and I already showed you the syntax that I'm going to use now. So I'm just going to place some boxes in this figure to show you like the basics of the layout. So here the first box is like first row, first 3 columns, and as you can see, it's across the whole figure, because the grid layout will kind of increase its size if you put stuff in it. And that's just a convenience feature. It's not like an array where you can't push things into out of bounds area and it will resize. MATLAB kind of does it like that, but it's impractical for plotting because you'd want to extend your plots all the time. And so they kind of grow with stuff that you add and readjust. Right, so one thing I also wanted to show was the layout inside the figure. So let's just say like F holds the figure now, right? So if I go to the REPL and I say f.layout, you can see that there's a grid layout here, which says it has, that's like the size of it in terms of rows and columns. So it has rows from 1 to 1, so 1 row. and 3 columns, and it has one child, which is this box that I just added, which spans from row 1 to the 3 columns. And so I'll add one more box in the second row, and you can see that it jumped such that both boxes now take an equal amount of space here. And if I look at the layout again, then you can see now the layout has 2 rows and 3 columns, and it has 2 children, which are the 2 boxes, and this one I just added in row 2 and columns 1, 2, 3. Okay, so another one, and then 3 vertical ones in the same vein. So yeah, I wanted to show like this grid pattern because it will soon tell you more about like how these grid layouts work and what like the layout algorithm actually does. Because if you want to really manipulate your plots well and get exactly the result that you need, then it's nice to know about this. So yeah, I'll add an axis to this first, right? At position 1, 1. Okay, so there it goes. And you can see that kind of the layout shifted again a little bit to take in the axis here. And I want to show like, if you look at where the boundaries of the axis main part are, like of the rectangle, then they match exactly this box that I placed there before, like the grid layout cell. As you can see, right, the every rectangle you see here, that's like an inner area or the inside of a column and a row. So in this case, like this first cell. And the axis decorations of this axis, so like the text here, that is outside of this area in the default mode. And you can see also that the gap between 2 rows, like row 1 is here and row 2 is this one, and this space in between is the gap. And you can see that it's bigger than the gap between row 2 and row 3, right? Because there's stuff in it now, like the 0, 5, and 10 is sticking out into this gap space. And this helps you to basically keep things aligned however you want them, and at the same time avoid overlaps, because the layout algorithm will push stuff away, and it determines based on the size inside the cell and outside the cell, like how the whole thing should adjust. And let's say I'll add a second axis across the first 2 rows and in column 2. And you can see that here. So again, if you look at the outside boundary, then here it kind of is on the top and the right and the left side of this cell. Then it spans across the gap here, right? And it again aligns itself with the lower end of the second row and here on the columns. Right. So the size of the second axis is like the height is the height of the 2 rows plus the gap between them. And as you can see, it also increased the gap between the first 2 columns now, because again, there's like text here now, and also the gap between the 2 bottom rows has also increased to contain these labels here. And the next thing I want to show is what happens if you add a differently sized object to it. And the thing about the color bar is that it's usually quite narrow, right? And I will place it across all the rows that are here, and that's the colon operator here, and in the third column. So the color bar will soon like take place across these 3 cells, and you will see what happens with the layout when I do that. So you can see that the third column completely collapsed to this tiny size of the color bar, and the other 2 axes have spanned outwards to cover the remaining space. And the reason is that a grid layout has different modes, I would say, in which the with which the sizes of the columns and the rows can be determined. And if I go to the layout again of the thing that we have now, You can see all the objects that I put in are in this layout now. And one thing about the layout is, I think it's called call sizes. Yeah. Right. If you check out, it's kind of an internal thing, but as I said, like I want to show a bit like how this works so that you get like deeper knowledge of this engine and can use that to your advantage. So the column sizes of this layout are all set to auto, and that's like the most common mode, which just means the layout will check if there are objects in the column that have a known width, and if there are any or multiple, then it will use the one with the highest width and set itself to that. And in this case, like the first column has only this axis and the boxes, but the boxes don't have a fixed size. They just adjust to whatever's there. And the axes are made the same way by default. Same thing in the second column, but the color bar tells the layout that it has a certain width, at least in default, in the default style. And this means that the third column completely shrinks down. And I think this is confusing to some people who start out with Maki, because then sometimes things shrink in their layouts and compress down, and they're like, why is this happening, and so on. It usually just is because the layout has an auto-sized column or row, and you put some object in there which is of known size, and then it collapses. So there are different ways to mitigate that, but usually it's behavior that you want, right? Because you don't want, I can show you a different way what could also happen, because CB is the color bar. I saved that here. And there's this attribute that all objects that can be in a layout have, and that's called this tell width thing. So tell width is like literally, it means, does the object tell the grid layout its width, right? And it's meant in this way that the object can know how large it is, but it can like choose not to take part in this auto resizing of the layout. And then if I set tell width to false and it's true by default, then you can see that the third column kind of ignores that the color bar has a certain width, and it just says like, I don't know, there's like arbitrarily sized content in here, and now all the three columns have the same inner width again. And the algorithm works such that the gaps between the columns, they don't count for like how much space a certain column gets. So the inner parts of these three columns, they are all the same size, even though the gap between the first two is larger. So that's also something to keep in mind, that that's how the space is distributed. So let's set this back to tell width true so that it snaps back, because otherwise there's just wasted space. And now I'll show an example of like things shrinking unexpectedly maybe, and how you can mitigate that. So there's this other object called label, which is just like a block of text that you can place wherever in your figures. That's usually good to have like a spanning label. It's very useful for all kinds of purposes. So in this case, I just make one called label and put that in like basically the one after the end row. So this will increase the number of rows in the layout, and the second column. So below this cell, there will be a thing called label. Right. So now the thing happened again, right, that I told you before. So now the grid layout goes in and says like, what sized objects are in column 2, and it finds only the label, and the label says like, I'm this and that wide, because usually you don't want arbitrarily much space for text, right? It's nice that the layout shrinks to contain it, but in this case, we don't want the column to be sized by the label. So what do? We say like tell width false, and then the column kind of ignores that. Right. And a different way you could do this is like if I set this to true, but I can go in and say like the column size of the layout in column 2 should be auto and then false, and this means that it will ignore stuff, and this should hopefully not crash. Yeah, so now it did kind of the same thing, but this will mean that the layout will ignore all objects that have known size. So I don't know, that might be useful in some cases, but usually like this default of auto true is like the most meaningful. And if you just want one object that is being ignored in terms of the layout, then you just set those tail width things to false. And then it snaps back. Right. And another thing to know about this resizing logic is that it only works for elements that span only one column or row, because it would be kind of ill-defined if an object of known size spans multiple columns or rows. It's not clear exactly how the space should be distributed. And so the choice that I made was just to not resize columns or rows in that sense. So if you do a spanning label, like this one goes again in one row below the ones that we already have, but across all the columns. So now nothing did collapse, right? Because even though the width of this thing is known, it doesn't belong to like one specific column that could adjust to it. So in this case, you will not get this. You will not get this behavior that everything jumps. And the same that I mentioned, of course, also applies to rows, right? So we only I only showed columns so far, but you can see that the vertical height of the height of the label here and the label here, each of those has like its own row, but those rows obviously take less space than the rows in which these axes are. So that's exactly the same mechanism, because the rows say, oh yeah, there's this text in here that's this high and that high, and I will just adjust to that. So I can exactly do the same thing. If I don't want that, I can say like L2 tail height is false, this time height, not width. And if I run that, then you can see the last row has now expanded, because the layout kind of ignores that there's an object with known size there. Yeah, you can just kind of have to figure out for your plots like which behavior you need. Sometimes it's this, sometimes it's the other, and I cannot predict that. So it has some default, which mostly makes sense, but yeah, if it doesn't do what you want, you just change it. Right. So let's continue with one more deeper example. So for example, we can give this. Oh yeah, I see now a question coming in on this big banner. Can you set all labels to just be tail width false by default? Yes, you can. I mean, we didn't talk about theming at all so far, but let's just briefly interject that you can, like for example, let's say with theme, and let's hope that this works now. Tail width is false. So what I'm doing here is like this with theme function. It runs one function while it changes the global theme. And there's a way to pass options to these different kind of objects that you can use. And the keys for those are like the same spelling as the constructor. So I am saying here that I want the default to change for label such that tail width is false. And I think, let's see. So like this, and another one in column 2, and another one in row 2, right? So the tail width is false, but the tail height is true. So let's see what happens here. Oh yeah, I didn't return the figure. Okay, that's tiny, but let's say font size is 50. Right, so you can see the rows snap together because the tail height is true, right? So this is actually like a tiny grid layout which just shrunk into the middle of the figure because there's too much space. But you can see that the columns, they have expanded. So yeah, that's the way you would do it if you wanted to. And you can also make that persistent by doing set theme, but that changes like your global theme. So depends on your use case whether you want that. But in this case, I didn't want to manipulate the main theme. So with theme is a good function to iteratively like work on a theme without it bleeding into everything else that you're doing. Okay, so I'll just do this thing again, just hitting on all these things that I did. So here's that figure again. with the label. And we were, yeah, I wanted to add a title to this axis. And if I do that, then you can see the layout shifted a bit to keep this title in here. And I think, I don't know, like, yes, matplotlib and co, and like MATLAB as well, and ggplot, all those. I mean, they all kind of do similar things, but I don't know. I mean, I wrote this because I was annoyed that I still had to fix overlaps way too often. And I think probably for those who have plotted a bit before, they know this overlap issue. And at least with like these objects, color bar, axis, and so on, you will usually not really get these problems, because in most cases they are just handled by this kind of algorithm and align issues. So yeah, I mean, you can make up your own mind if that if that works for you, but at least for me it works most of the time. And one caveat that is interesting, and sometimes people ask me about this, is that the extent of the X labels in Y direction, so how far down do these labels here extend, that is incorporated into the layout, but not how far a number might stick out to the right here. And this is, the reasons for that are a little bit more complicated, but it's basically that the size of the, whatever size the layout tells this axis to be horizontally, it's not supposed to change how far out things stick on the side. And the thing with these axis labels is that if the size of the axis changes, they move as well, and they might go further inward or outward if the tick is not exactly on the outside here. And so that would be like the cyclical dependency. And so it just ignores that. And sometimes this might, again, cause overlaps. So Maki is not completely free of overlaps. I would be selling it too much, but like in most cases it does. And if you get this kind of issue, then you can just increase a column gap a little bit to get the behavior that you want. But this kind of tweaking is usually, luckily, not required because the defaults usually leave enough space. So in this case, I wouldn't even care, right, that it goes into here a little bit. There's space enough. So the next thing I wanted to show were the different align modes. And that's also like a deeper, you won't need this on like your first plots, but yeah, this workshop was a little bit like going also into more specifics, I think. So I wanted to show this because sometimes there's this problem that you want to align some object, like this axis, you want to align it differently. So the default, I can show you, like if we go X2 align mode and look at this, then you can see it's currently set to inside. And what it means is that the inner part, like the inner part of the axis, maps onto this area of the rows and columns. And the outer part of the axis, which is like the decorations, they fall outside of that into the gaps, right? And sometimes you just don't want that for whatever reason. Okay, I hope you don't hear I have neighbors moving in and they have a really loud drill. So I hope it's not horrible sound right now. All right, so yes, one good example of where you need a different align mode is already happening in front of our eyes, but it's not obvious from just looking at it. But the main grid layout of the figure, it has a different align mode, because if I placed stuff such that it aligned with the inner part, then all the axis decorations here, they would bleed out of the figure, right? I mean, think about it. If this axis would map right to the edge of the screen with its inner part, then the 10 would fall outside of the, and the 5 and the 0, they would fall outside. I mean, I can kind of show that, I think, if I take the figure layout, yes, and I look at that one's align mode, you can see, okay, it's kind of messy, the printout, but yeah, it has an outside align mode with like a padding of 16 applied in every dimension. And if I change that to inside, which I can, then okay. Oh yeah, okay. Now I did this thing where that was a good example. I think I just replaced the the observable. Let me just see if I did or not. Okay, yeah, I didn't. It's just not hooked up the way I thought, but that doesn't matter because usually you don't do it like this, right? You set it up in the beginning. But now I set the alignment to inside, and you see all the decorations, they popped out of the figure because now the inner parts of every element kind of go right to the edge. And I mean, that's usually not what you want, right? So that's why the default is like outside, and let's say again 16 like it was before, and I'll call this internal update function again. Right. So now everything is back inside again. And I'll show the same thing with this axis here, with the big axis. Let's say I didn't really want this line of the axis to align with that line of the other axis, but I somehow want the top part of the title to align with this, and I want these tick labels to go inside and these also. Then I can change the align mode to outside. Right. So you see now this thing is now contained inside this rectangle, except for the 0 of the 10, which I talked about before, right? That's the thing going to the side that doesn't kind of count. But here the thing just like it moved into this rectangle. And sometimes that's exactly what you need for a certain plot. So it's nice to nice to have seen it before, I think. And I can change it back to inside. Now it's as it was before. And there's also like an even more specialized case. In some cases, you want one part of the outside. I call those like the protrusions because they like protrude from the main part. Sometimes you just want one part of those to move inwards. And so you can go and say align mode mixed bottom 0. And now it applies like a padding of 0 while taking the bottom part into the space. We can do something similar with like bottom 0 and top 30. So this time the title will move inwards and get an additional padding of 30. So you can see there's now a gap. And that's kind of the same thing that figure itself does, right? So the outer padding, as I told you before, that comes from this align mode. And another thing, I mean, I showed the call size command, but like there's also the column gap command, which you can apply on the layout. So in this case, we want to set the first column gap to like 80 units, and then the thing spans out. So if there's really like too much going on here and these things fight with each other or overlap, then you can set that as large as you want. Right, that's what I wanted to show about this. And the other thing, okay, I haven't really looked at questions in a while. I'll look soon after I do the next example if there's anything I should cover. So the next thing I wanted to show, because it always crops up, like people want to plot plots with certain fixed aspect ratios all the time. And what they usually do is they find the aspect attribute of axis, and they know from other plotting software that that's what you usually do. Like you take the axis and you say you are now a square axis, and what that looks like is if we plot like this figure and put, I have some setup code here, but okay, maybe no, it's fine. I'll do the whole thing. I think it's fine. So what I'm doing here is to demonstrate. I'm doing two separate grid layouts that are nested inside the grid layout that I have. So one is in the first row, the first column. The other is in the second row, the first column. Right, GL1 and GL2, and I can place an axis placed in the subgrid layout, and I give it aspect as 1, and I place a box next to it. And so now the box has one of the columns in the first grid layout, which spans this first row, and the axis has the other column. And you can already see that the axis is square, but there's like white space here and white space there. And so now I'm putting stuff in the second grid layout, which is currently empty. I'm putting in an axis again at row 1, column 1, which spans like the whole nested grid layout in the lower row. And I place another box here. So now this is the default thing where no aspects are set. And now you can see the box has the same inner size as the axis, but we want the axis squared, right? So what we can do is on the layout level, we can say we need the first column which now has an auto size I showed you before, we needed to have an aspect size. And aspect means that the layout algorithm, it kind of computes all the other columns that it can, and then it tries to match the size of a column or a row to an opposite column or row with an aspect applied. So if we set the column size of the first column in this sub layout here to aspect 1 and 1.0, I wrote this as a float so you can see it's different things. So the first one refers to which index of the opposite side you're talking about, right? So in this case, this lower grid layout just has one row. So obviously we can only specify an aspect versus this first row. And the aspect that I want is 1.0. So that means this first column will wait and see what the row sizes on the other side are. And then when it knows what row 1 has for size, then it will adjust itself to be aspect 1 relative to that. And if I do this, then now you can see the box filled the remaining space because it has an auto-sized column and it just waits what space is available and then it just fills itself and into that. But the axis is square and the layout is kind of correctly filled with this information. And I can show you now what happens if I adjust this figure like for different figure sizes, right? You could be lucky and have a figure size like this and it wouldn't make a difference. Like you wouldn't even see that the two are different. But if it's like wide, you can see the top has a lot of wasted space because what the axis is actually doing is it tells the layout, I don't have a specific size, so it gets like this big rectangle to work with, and then it just goes in itself and says like, actually I want to be aspect of 1, and then the rest of space is kind of lost. Where in this other case, the layout knows that the first column and the first row have the specific relationship, and then that's a really common thing you want to do in your plots if you have aspect sizes. And obviously, you cannot put in too many of these aspect constraints, right? Because let's say I also wanted the box here to be aspect sized, but I don't want an aspect like a square aspect, but I don't want any space to be lost. That's kind of impossible because you cannot put two squares next to each other in this space and expect it all to fit, right? So that's one really important thing that you should have seen. And the last thing I want to show is like why not do this with the row size. And let's just do this example again up to the point where I did the column size. And if I said to the layout, just make the first row with an aspect of 1 to the first column, then the algorithm would go like, okay, what are the column sizes? This one is that big and this one is that big. And then it goes say, okay, the first row is now 1 relative to the other one. And you can see that this doesn't fit, right? It doesn't make sense, at least. So the order matters because the algorithm really waits to see what sizes other things have. And if in this case, the columns just already take the space that they want, then this messes things up. So often you will just want to check what you did here. All right, yeah, that's what I want to show, and I'll give back to Simon, who will go over recipes.
All right, but maybe we should have a break first.
Oh yeah, good point. I mean, we did start later, so I wonder, I mean, we can see how far we get. But yeah, you should, like, how much break do you want to take?
5 minutes.
5 minutes, okay. Yeah, now let's be back at, yeah, in 5 minutes, 17:47 or whatever, something like that.
Yeah.
Okay.
All right. How do we even do this? All right, welcome back. I guess we start by answering the last unanswered question.
Mm-hmm.
Julius, I guess that's for you.
Okay. Yeah, my connection just broke a bit. I wonder why. Okay, can you hear me now? Good. All right, I'll just quickly share the screen again. Like, how can you put a box inside a box that you actually want to overlap? I can only try to interpret what that really means, but I imagine you want to see something like this. Okay, again, like the. Okay, so let's say you want. Okay, you have a figure, and we put a box across this whole thing. That's just like in the first cell, and we say its color is gray 50 or whatever. So let's see how that looks. Okay, so that's like a box, and I say now overlap. That to me says like you want like another box that's kind of inside here. If not, then sorry, but I would do it like this. Because we want like a padding towards the boundary of this box, I just say like, okay, let's put another grid layout in here. And this grid layout has align mode outside, so it kind of keeps padding towards the outside, and we just give it some padding value, let's say like 20. And the way you put that, wait, I think we can actually do like this now. Let's see. Right, so that doesn't make any visual difference, but now there's this grid layout here, and if I place further stuff into that, then now we put that into the grid layout, right? At position 1, 1, and now we say color is tomato. I really love the tomato color for some reason. Yeah, there's the box, inside the box, overlapping it with like padding, and now I could do like more boxes like that. Color green like this. Right. So if you wanted to do like a figure where you place stuff in different boxes and want to highlight it this way, then that's how I would do it. All right. Back to Simon.
All right. Let's talk about recipes. Here we go. So recipes in Maki have kind of an interesting history compared to plots.jl, because I always thought about them in a very low-level way, and just to build up basic new graphic types, and they're still kind of that way, which made it a bit hard to make these kind of high-level recipes with the whole layouting system and everything. But yeah, I'll just show you how to write your first simple recipe. I'm going to show how to make a little graph plot recipe where you just pass vertices and connection. And the syntax here has multiple parts. So that's the name of the plot object, and the lowercase version of that will be the function name you can call to directly call into this. These ones are the argument names of this plotting object. And then you have this do block with the scene. The scene is just a convenience because sometimes you may want to access them to, e.g., inherit from the scene theme. So you can do something like this to get like the current color from the current scene theme. But yeah, these are the keyword arguments. And if we look at what this macro actually expands to, we I wrote this out here. It's heavily reduced pseudocode because it's a bit more complex than this with all the observable things. But in simple terms, it just defines this graph plot function, which then gets used to create this combined plot type with the graph plot function as an argument so that you can differentiate it and dispatch on it. And that becomes an alias to make it more easy to actually work with it. And then this attributes thing here ends up in the default theme function and gets returned and invoked then with the current scene that the plot object gets plotted to. And then we have this main important overload, which is the one that's most heavily simplified because there's quite a complex plotting pipeline to enable that you can pass a figure, can pass an axis and a scene and all these kind of things, and then also make it work with observables. But in simple terms, it looks like that. In the end, if you call graph plot, first the positional arguments get converted and passed to convert arguments. Then the theme is applied from the default theme to the keyword arguments. And this then gets passed to the graph plot object. And this creates this object. And that way, the plot object already exists before actually going into your recipe code, which happens then here in this overload, where you can add new plotting functions in there. And then it just gets pushed to the figure-like, which then in the end is usually the scene because the axes themselves don't really hold this. So yeah, to actually overload a recipe, we need to overload this function as pointed out before. Here we have then the argument names we can directly access from these here. So we have vertices and connections. And likewise, you can also access the attributes like that. So vertex color and connection color in this case. And when we execute that, we should be able to get our first recipe going. So let's try our first one. Just pass the color down. So we have them all stored in this plot object. And this might be a bit weird, but you basically use the existing plot object instead of a scene and just plot into this. And that way you get this kind of combined plot. And if we try this out with some data I prepared, we can see that we get the circle as a nice scatter plot so far. And then for a graph plot, we also want to have the connections. And yeah, I already prepared this in the finished app so that we access the connection one, which is just like an array of tuples, so which defines the segments that should be connected. And all of these attributes here are now observables regardless of what you actually pass to the functions. That's what makes the recipes a bit harder to work with than, for example, in plots.jl, because it could always just change. But it also makes it as a default that you can interact with these kind of new recipes, plot types. And then, yeah, so we just go through all the connections, push the points in here, and then actually draw them with the line segments. So if we do that, we should get the connections as well. And not to forget, we actually defined a color here as well, so we can pass that down as well. to actually get this grayish color here as a default. I guess there are no questions. Good. Yes, that's a very basic recipe to get you started. And then a lot of people have the difficulties what's done in convert arguments and what's done in this kind of recipe code. I think the recipe is when you want to have a lot of control over all these observables here and want to update them separately for performance reasons, because in convert arguments, everything gets updated at the same time. So if any of the arguments changes, the whole function gets run again and again. And here it's really fine-grained. But one good use case for convert arguments here is if we actually wanted to turn this into a bit more nicer high-level graph recipe that actually accepts a graph from graphs.jl. Then we also need network layout, because graphs need to have some kind of 2D layout to plot them actually. And to keep it simple, we just find all the connections in the adjacency matrix. Then for now, we just hardcode a layout algorithm that we are using, and that spits out an array of points, which we then can pass basically to the recipe. So what you return here will end up in these arguments here, as you can see here. So that's pretty much then what ends up in the plot object. So if we define this, we can then just pass any of the pre-made graphs objects in here. And tada, we can see the wheel graph from graphs.jl in here. This is all interactive, as I said, so we can actually take a look at this plot object. So that's this combined object here that I talked about, and you can access all these attributes here. So you can change the vertex color to blue, for example. And you could also look at this here, because that's just the array that holds the subplots in there. And it's a bit hacky, but you could also then just go in here and go into the scatter plots and, for example, change the marker size immediately. So yeah, this is all interactive. You can also access the arguments by their position. So one was our vertices. Oh no, in this case now it's from the convert arguments, it's just the graph. So we can actually give it a different graph, for example, one with more vertices, and then update that. Now we don't see anything, that because the limit changed. And with a double click or with reset limits, we then just see the updated plot. So that's a very easy way to already animate and interact with this new recipe we have. And yeah, from there we can try to see how to interact with this graph plot. I want to make one where you can just drag around these vertices here. So right now there's another interaction registered there, which is the zoom rectangle from the axis, which you would need to disable first. This can be done with deregister or deactivate an interaction. So right now I'll just deregister it completely, the rectangle zoom. And now we don't zoom in anymore if we drag. So like this, we can actually start adding a new interaction. How to do this? Let's first of all look at the main API for this, which is add mouse events. It can be added to any scene, and then we get this handle back here. So for example, if we go into the x.scene, which is the scene in the middle here, we can just display it for a second to see what it actually shows. That displays in VS Code. So that's just the main window without the axis decorations. And if we add mouse interactions to the scene, we get this event here, this handle. Which has this field here, which is an observable that you can register function callbacks on, which works with the on function. So you can do something like this on event, and then show event. And now I need the terminal. Here it is. And now we get all these mouse events here spit out. Can also inspect it like this. I need to keep this again. Events. Some events, and then we can look at it. So the data is just a point in data coordinates. So if I'm here, it should correspond to this point in data coordinates, which means all the transformations from the scene and axis are applied to it. There's also a corresponding one with in pixel coordinates, so that's then in the window coordinates of this. So if we actually want to draw these, the data one is very easy. That's the one you would actually draw to the axis itself. So let's start with an anti-observable, scatter that to the X. And then now on mouse events, we can just update this observable with the new data. In the first place, or we could actually just replace the whole array for this. This is easier. And then we should see that there's now a point following our mouse in these data coordinates. If you want to actually do the same for the pixel coordinates, you would need to draw it in pixel coordinates, which can be done, for example, with creating a subscene with only a pixel camera applied as a transformation, which there's a convenience constructor for that. And pixel it's called, and without the bang, it returns a new scene. So if you plot to this, you will need to plot in pixel coordinates. So just to give you an example, pixel scene, and then for this. There we go. Then you would go from pixel 0 to 500 here. I should disable the plot plane. And that means if we do the same here, let's start from new mouse events, then this time plot this observable to the pixel scene. Then we can actually use the pix data here to update the observable. Now I displayed the scene. And now we also get it mapped to the correct position. This is pretty important if you kind of trying to move something in data space, which is usually your plot, and trying to pick something, which is usually in pixel coordinates. So it's important to have both of these coordinate systems working. We can also do this whole thing in the recipe itself. It's not that clean in the moment because you actually need to get access to the scene, which you can by getting the parent scene. But we want to, for Maki 1.0, we want to have a different API for that so that you can also register for access events and things like that and not manipulate the scene directly because, yeah, recipes shouldn't really mutate the scene as much in that sense. But yeah, let's try to implement this kind of mouse track to drag a point around. I already prepared something for this because it's a bit cumbersome to go through all these events and figure out what to do one after each other. But yeah, let me step through it. So first we get the scene, then we do the same thing as before with getting the mouse event here. Then we actually listen to this mouse events observable as before. And this one has a type, which is left drag start or left click or left drag stop. And we just care for these three right now. If we want to have a drag start stop action that then just moves around the vertex position. And yeah, so once we start a drag, we look if we are hovering above the scatter plot here, because that's the one we want to move. And the pick API returns the plot you're hovering above in the current scene, and with an index, for example, in a scatter to tell you which scatter you're hovering above. So then we can here, actually it's a bit more cleaner if we just say scatter plot, this one here, because this also returns the plot. And then we can compare the return plot from pick, if that's the one we're interested in. And then we can set the index of the current vertex we want to move. Yes, and that's how we start our drag. And then the next event that's interesting is that we are currently dragging, and we should only do something if the drag index is set, because we started by picking the right plot. And if those conditions are true, we can then actually manipulate this vertices array object that is actually being plotted, which we do here. So at the drag index, we need to set the new position, and because we want to drag it, it's the mouse event in the data position, so in the same coordinate space that the plot is in. And then we notify these vertices observables and the connection one, because they both then need to change after we directly manipulated the array in here. And then if we are stopping, we just need to reset the drag index, because then we are done. And let's see if this works, because I actually changed a bit. One thing that we already want to change is that the scatter plot should come after the line segment, so that it's above the lines, because that makes the picking easier. And we might want to make the marker size a bit bigger. And that looks much better. And nothing happens, of course. Let's see. But that brings us to debugging these kind of problems. Yeah, let's first start by actually seeing the event. So we see this is actually not even called. Why is it not called? Because we added to the wrong scene. I see. So now we should get the events, and we get the dragging, and we print a lot of stuff because I added this here. Yeah, so this is one kind of simple and complex interaction that you could add to recipes. You could also just have this as a convenience function to add this to existing scenes where you already know the plot types inside. That's a bit of taste. I would maybe recommend right now, if you're in a package, to not add it to the recipe, because we want to rework the API and make it more official how to do these kind of interactions. And until then, leave it out of the recipe. But it can be really nice to also just create interactive recipes like this. Yeah, while we're talking about experimental features, people have been asking for more complex interaction with the recipe system. So for example, having in convert arguments actual keyword arguments here, so that, for example, you could change the algorithm in here, which is currently hard-coded, which is possible right now, but not heavily talked about, because it's also a bit of an ad hoc API that is not as clean as I would like it to, because you actually have to overload a function like this to advertise which keyword argument you would actually listen to. And why it's so complicated, that's because in here, with this keyword arguments going in here, they are all observables. So if you just always pass them here and listen to all the changes from everything, the convert argument function would be called for a color change, even though nothing in here relies on the color. And that's actually the reason why only keyword arguments get passed to the convert argument function that are advertised by this used attributes, which could be multiple ones here. So you're returning a tuple. But once you actually overload it, you can then have a keyword argument right here. So we actually move this out of here. Yep. It's a bit confusing with so little space. Right, like this. Then nothing would change much here. Let's try a new example with a new kind of graph, and then actually pass it a different layouting algorithm. Which takes a bit to lay out or compile, and then we get a differently layouted plot like this. And all the interactions and everything still work, of course, because all of this happens actually earlier in the pipeline. And then if we remove this, we can see that the layout looks different. Yeah, this is a bit doomed for change, I think, once we really start working on the recipe system. And I hope once I work more on Maki that there will be more time to overwork things like that. There's also the other a bit of experimental API where you can return whole plot objects from convert arguments and therefore then actually pass arguments. And the way this works is if you have your own struct, like a very simple one like here, then you need to actually overload this a bit funky signature, because that's what's getting passed down to the dispatch then if you're calling, for example, plot my graph, because at this point we don't really know where this goes yet in terms of if it goes to a scatter or if it goes to the graph plot thing. But then we can actually just return a plot spec with the plotting type we want to target. And one thing is here as well, it doesn't recursively apply convert argument. So if it's not already in the right form, we need to apply it manually. But then we can pass this kind of attribute here on top of things. So let's just define this, my graph. Let's just use the same graph here. And then we should see that this works with the new attribute from here, which could also then be stored in this struct to make more complex convert arguments once. Yeah, but this was cooked up for algebra of graphics ages ago and hasn't been really maintained or documented since then. And I think we want to make it a bit more nicer before we heavily advertise it. But it will be quite similar, I think, the direction that we have some kind of plot object that you can return that then gets plotted instead of like the arguments, and basically skipping parts of the recipe steps. All right. Are there any questions? So there's this question, which I think Julius probably has a better answer to. Can we return from the rectangle zoom using the left arrow key? I don't think so, right?
I tried to answer that in the chat. I understood it such that I think when you reset the zoom, right, that you could do that with the left arrow key. So yeah, you can call reset limits. You can hook that up to any kind of keyboard event that you want, but the default is control left click. And we don't really offer much of a way to change that right now, I think, because it wasn't contested by anyone so far. But yeah, I think these things, they change over time a little bit. Like if you add more things to the interface, then you start seeing that you have to add more options for people to or move things around a little bit. So in principle, you can do it, yes, but currently we don't make it terribly easy to do.
Yeah. Then is there a standard control box like in other plotting packages with common events and interactivity? Not yet, but I think the widget library in Maki is now advanced enough that we could add it at some point as an optional feature. I guess most of the mentioned interactions like home, zoom, pen, save, fig are implemented. So it would just be a matter of creating a button for it. You already answered this. Predicted date for Maki 1.0. That's a tricky one because we've been moving that always because, yeah, the recipe changes never really happened because it's kind of hard to work on such a complex topic just on the side without having like real time dedicated to it. I think that will be the main breaking change for 1.0, besides of a few small other breaking changes, but we're too shy to from some time to time break a few small things. But if funding and everything goes well, I will be able to work more full-time on Maki, or at least half-time, then maybe middle of next year or something like that. It depends a bit, but yeah, it would be really nice to figure out lightweight recipes and high-level recipes that can interact with the layout. Can you have interactive pop-up boxes to mutate properties of future plans? I think you kind of can do this these days, but it's definitely, there's no nice API for it. Frederick Fryer actually added in one of the newer releases that you can have multiple windows. So, for example, if you do something like this, yeah, so that's a Maki feature. And you can open a new window, a second one. So it would be possible to create a pop-up window with that you can close again. But yeah, nothing is added to this yet. And I guess you would want to also hide the decorations and stuff like that. But yeah, that's still a bit further out to make it really nice. All right, maybe we should jump to the next part because otherwise Julius will run out of time for this really beautiful app.
Oh yeah, I mean,
I will try to answer some more in the chat box.
Sure. Okay, what's still standing? Like we wanted to talk quickly about, I think sizes and units, like a 5-minute thing. I just briefly want to show that because it's asked pretty often. And then, yeah, one more interactive app example. Okay. Do this again. So where did I have it? Figure size. Right. So one question that we often get is like how to make, if you make a figure for publication, right? You usually have some physical size you're targeting, some like, I don't know, I picked up something like Nature's full width figure, for example, is 183 millimeters wide. And so the question is, how do I make a figure with Maki that has that size? And what do the units even mean when you specify a resolution of a figure? And the way it is right now, so I put here the question, what units does Maki use? Pixel, point, centimeter, or whatever. So the thing is that each backend has different output formats, right? So GL Maki, you can save a bitmap, like a PNG. With Cairo Maki, you can save both PNGs, but also vector graphics like SVGs or PDFs. And each of those formats has different ways that a dimension, a physical, or like a size can be specified. And the thing is that basically pixel graphics, so if you have like a 500 by 500 pixel sized image, that basically has no physical size, right? If you wanted to specify a picture for the nature full width figure of 183 millimeters and you wanted to specify it in pixels, you can't, because a pixel is just like, it's just a thing on a screen basically, and it doesn't have a physical size unless you have a intermediate metric like how many pixels per, I don't know, like centimeter you have, or pixels per inch or whatever. So something you see sometimes is like a PPI thing, pixels per inch, or something similar to that is DPI, or dots per inch. And so those things like dots were printer dots, but sometimes people just use it interchangeably with pixels. So you cannot save a pixel sized image in a physical size unless you decide what kind of DPI or PPI you're looking at, right? So that means you have to do it like in reverse. If you have, at least for the pixel sized images, so if you have a physical size that you want to target, so like 183 millimeters, and then let's say you say, I want 10 pixels per millimeter, then you would say like times 10, that's the amount of pixels that you have. And then the thing would have to be like 1,830 pixels wide. And then you could go ahead and do like a figure where you say resolution is like 1,830 times whatever you want. And this, if you saved a bitmap file with GL Maki, it would have exactly the number of pixels that you want, and at your DPI or PPI that you chose, you would get this size. But for publications, we often don't specify, we don't use bitmaps so much, but we try to use vector graphics. And vector graphics don't specify their widths in pixels because they don't have pixels, but they use point usually. And point, or like PT, is a measure that is actually by definition usually tied to other physical metrics. Like 1 inch is usually 72 points, at least in the way that Cairo uses it, which powers Cairo Maki. So that's the relevant one for us. And 1 inch, of course, like 2.54 centimeters. So that with those, if you specify a plot in point, then it has immediately like a physical size. And so in this case, like, because Maki doesn't really use units, it depends on how the numbers that you give the figure size, how they are interpreted when outputting the stuff, right? So, but if you wanted to save a vector graphic with this width of 183 millimeters, then you would say, okay, how many inches are in that millimeter size, and then times 72, that would give you the number of points. And point is, if you save a figure, if you save an image with Cairo, then it uses points if you do a vector graphic. So that's the number that you want to target. So let's say we do this, that would give us 518 point something points for the width. And then we'll just say like some height relative to that, let's say like with a ratio of 2 to 3. And now I can make a figure with that width and height and points. And I should actually activate Cairo Maki because it's meant for that. So now I do this figure and I just add these 3 things to it. Right. And so now you can see an image here. I'll pull up the screen a bit. Right. So this, because Maki is currently in bitmap format, now the dimensions that we gave to it have been interpreted in pixel size, right? So this thing is actually 518 times 345 pixels wide, and that's not a lot. So you can see it's pretty blurry. The way you change that is by calling activate with the type that you want, and I'll change to SVG. And I also set, just for demonstration, I set this extra keyword points per unit. And so this means how many points is one of these unitless numbers interpret when I save. So I call this and then I do the same plot again, just like this. And now you can see I have exactly the same plot. So if I go back and forth, the dimensions are exactly the same, but this one is a vector graphic and this one is an image. And the reason why I chose 0.75 here is that it's kind of like a web standard that they, whoever implemented those web or wrote those web standards, they chose that by default a pixel is related to a point by this ratio of 0.75. So if you want, in web context, if you want a vector graphic that has the same size that the browser chooses as a bitmap, then kind of the dimensions of the vector graphic have to be 0.75 that of the pixel graphic, right? So if I go back and forth between those two, you can see there's enough space. That's how you know that the image here is not squished or anything. That's the size that the browser wants it to take, and it's the same for both. But of course, the bitmap is very blurry. So if we change back to PNG, we can do a different keyword, which is not point per unit, but pixels per unit. And the default is 1. So the default is chosen such for those two, 0.75 and 1. It's chosen this way so that in a Pluto notebook or Jupyter notebook or whatever, by default, the images will have the same apparent size. But often the pixel resolution of this is not enough for us. So what we can do is we can dial that up. We can say, if I specify a figure with a certain number of units in width, 518, I can just interpret 1 unit as 2 pixels with pix per unit equals to, falling back to German here. Right. So if we do that and call the same thing again, then you can see now the plot became bigger until basically it has to be forced smaller by the remaining space here. But it's also much less pixelated, and we can even dial that up further. Pix per unit is 4. And now, I mean, I don't know if you can see the difference, but this is pretty fine resolution. So that's how you choose that. So bitmaps, as I say, they don't really have a physical size. The physical size of it is kind of related to it only via web standards or whatever conversion you choose yourself for the print medium that you target, if you print at all today. Say that's the last thing I want to show. If you, or those two things, if you then save a PDF, I would recommend if you want all your methods put in, for example, what the font size is and what the line width is, if you want all of that to just mean point, then you just set point per unit is 1. Then the two are the same, right? And then if you save this figure with this particular resolution, 518 and 345, you save that as a PDF with point per unit is 1, then you will get exactly 183 millimeters in size, and the font size will be 10 points and so on. So that's how you do that. Yeah, and remember that it's 0.75 by default, because for interactive display, as I said, it matches pixels and pixel-based graphics and vector-based graphics. Yeah, and the only other thing that's left here still is what happens if you don't want to size your figure by some external metric, but you want to decide by the content how large it should be. So we can execute this code, which makes a good point. So this actually, I need to make those larger. Let's say we have a figure and we make some x's in those and give those fixed sizes of 200. that's too big for the figures. So you can see they kind of bleed out, like stick out at the sides. There's this function called resize to layout. And if the content of your figure has known sizes, then it can compute what space is needed for that. And if you run the whole thing like this, then you can see it jump back now just because the plotting pane kind of scales the image back, but you can see that the content now fits and the figure has, how do I check that? Yeah, it has a size of 763 by 1011 now, while the default is something like 800 by 600. Yeah, that's how you get physical sizes. And I think with that, I'll jump quickly to the interactive example because we're running kind of out of time, even though we started later. Might draw over like 5 minutes or so, maybe to finish that. Okay, so I'll close this and that as well. And the file that I wanted to show was like where was that? Oh yeah, image viewer. Okay, so I'll probably have to go over this a bit more quickly than I planned to, just because of the time. All right, so the idea, I'll actually execute, I think, everything for once, so you can see what we're trying to build. The idea was that I just downloaded some JSON data from the NASA day of the picture of the day site, and I wanted to make like an app that can scroll through these images and show some statistics on them. So in the repository is already the JSON file with all the info about those images, and I'll just run these functions so you can see it. To take a small moment till it shows. Yeah, so that's how it looks. And so you're supposed to be able to like go through here, click on the next image, and then it will download that from the internet. Takes a small moment, and now we have a different image. And here on the side, you have a histogram of red, blue, and green channels. And if I zoom into the picture here, then the histogram updates to only display the pixels that we have selected currently in this area. And so yeah, I want to show how you can set up something like that. And I think I'll probably explain it now with the actual code that I wrote. I was planning to go more like step by step, but I think we don't have the time to do it quite like that. All right, so yeah, and the idea is to use observables, and I think we have seen those a little bit, but it can't hurt to see them a little bit more. So we start by opening the metadata that we have from this JSON file. So if I would just run this, then I'll close this for now. Then in the REPL you can see like some data. It has like a date, it has some explanation what the image is, and it has like a URL to the image and a title. So what we want to do is we want to use an index into this array of however many images there are. I think like length metadata, like there are 343 images to choose from, and we want to dynamically like load images from the web and show them in Maki, and then hook up all these these histogram statistics to them. And the way you do it with observables is that you think about how does the information flow through this app. It's like a bit like this reactive way of thinking. And the base thing is the index into this metadata array. So which image you're currently in. Huh?
It seems like your screen share has frozen. Maybe you can restart it.
Sure, I can try.
Although now the cursor blinks at least.
Okay.
Well,
can you see it now?
Yep, there's quite a delay on YouTube. But
okay.
No.
All right. So hopefully it doesn't freeze now. So okay, we start with the index into the metadata array. So nth image that we want to show, right? And we start with 1, so the first one. We make an observable with 1 integer in it. And now we use the lift syntax to derive other values from this value and to derive values again from those intermediate values and then feed those to plotting functions. And so the syntax that I often use is the macro syntax with @lift, which means that every expression with a $sign in here references an observable and tells this expression that we want to derive a value from it. So my entry, my metadata entry, is always the index into metadata with that comes from this observable, right? So right now it's the first index. So if I run this, then my entry is now an observable of some JSON object, and this first entry is this this Tor's helmet image with this particular URL. And so now we can lift the next kind of piece of data from that, and we say our image data is, we lift from the entry, and for the entry we call E. This is like an anonymous function syntax in Julia for those who haven't seen it. So for an entry E, we pick the field E URL, which is then this here, apod.nasa.gov, whatever, like a JPEG file, and we pipe that into the function load image. And load image just takes the URL and uses this just like a special syntax to write it more nicely in a sequential fashion. It uses HTTP to get the URL, extracts the body from that object, puts that into an IO buffer, which then can be passed to the load function, which extracts the image. So, and the whole thing is memoized so that for the same URL, we only load the image once. That's what this is doing. Right, so if I execute this, then it will load an image from the internet and put that into this image thing. And we can see now that the type of this inside the observable is now a matrix of RGBs, so an image, basically. Right, so what can we do now with this image? We can, of course, try to plot it. And the function for that is, in Maki, is usually the image function, aptly named. So yeah, what we can do is I can just make a figure here and add an image plot to it at position 1, 1, as we saw before. And I actually don't pass the image in as is, because, and that's like a peculiarity in Maki or in Julia maybe, because the storage of an image is usually that the first dimension refers to the rows and the second dimension refers to the columns. But if you plot an image in Maki, it determines that the first dimension is X and the second is Y. So that's kind of flipped from how you normally think about it. So to plot it here, I actually flip it back with this transpose operator. And I also reverse the direction of the y-axis, and that's usually how you plot images. The y-axis kind of counts down pixels, and the x-axis counts over to the right. And in this case, I set the aspect of the axis to data aspect, so the image isn't skewed. You can look at this here. So that's how it looks. Like if we don't set the aspect to that, x-aspect is, what was it? I think nothing. Yeah, if we don't set that, then it's squished, right? So x.aspect is data aspect. Then we get this nicer view. Then we can hide the decorations of this axis because we don't really need like the pixel numbers here. Right, so we already have the image. And the interesting thing is that plotting a new image should already work. We had some trouble with it before, like in this streaming scenario, because I think it just taxes my GPU in a different way, but I'll try it here. Oh yeah, it actually worked. So if I change the index observable to 2, now the thing runs in sequence, right? It downloads the next loads the next entry from the metadata with index 2. Then it loads the image for that URL and that entry. And then automatically, because we passed this observable to image, it automatically changes the image here. The only thing that didn't change are the limits of the axis, which you kind of have to do yourself, but we'll see that in a bit. I can control click to reset that though. So this is how it would ideally look. So we can do the same with like 3. Now it actually has to download it from the internet. Yeah, and there's the new image. And right. And as you can see, the title I also lifted from the entry, right? So the title also changes to be correct. And I did that with the @lift syntax, and I just took the title from the given entry. So that's nice. Like we only have to change this one number, and then the graphic already changes, which is usually a really nice way to specify the flow of your logic. Okay, so now the idea was to display like a histogram, a color histogram on the side. So what we can do for that is we make another axis at row 1, column 2. There it is. And now we think about how this histogram should be computed. And my idea was that that I want to actually incorporate the limits of the axis to decide which pixels to bin. And so I define first like an observable that can hold any data type. That's just like a convenience thing now, because I don't know what the exact type of a subset of this pixel stuff is. So any just means I can worry about that later. I define this observable. It's empty. There's nothing in it. And now I say, whenever image or the limits of the axis change, I want to change something about this observable. And what I do is I look at the axis limits. I look at like from x to y, from low x to high x, from low y to high y. Then I clamp those values, which will be floating points if I zoom in, because like the axis can have arbitrary limits. I clamp that to integers because I want to index into the image, right? And so I determine what x low, x high, y low, and y high are in terms of the image. And then, as I said to you, like the data is actually plotted in reverse on the screen here. So it's a bit weird that I index with y first, but that's just how it is. And then I take a view of the image data at the limits that I have and put that into the subset observable. And this will now, whenever these two values change, the subset will hold a view of the image. And then, because I told you before, right, if the axis limits, they don't change by default if you change something about the plots. So because the histogram will have different numbers of bins, I will reset the axis that holds this thing later. So we don't have a histogram yet, but this is like presented in advance. So if I call this, and then nothing has happened so far, so the subset is still not assigned. There's nothing in it. But if I notify the image observable, which just means like call its listeners, then this function will be fired, like it will fire. And now subset will contain a view of this RGB thing. So this is like a subset of whatever of this image is currently in view. And with this, we can continue further, because like that's the subset of our image. And now I define the 3 histograms. And here we can see 3 hist calls. That's the plotting command for this. And to that, we want to pass a vector of numbers, right, that can be binned. And you can see here 3 times a real similar syntax to do that, which is @lift. Then I refer to the subset observable. And once I take all the red values, once I take all the green values, and once all the blue, and I make those into a vector as well, because the histogram doesn't expect 2D data for what I want to do, but 1D data. And I also set the bins to go from 0 to 1 in 256 steps. And the first one gets a red, the second one green, and the third one a blue color with some transparency applied. And so if I do that now, that's the red one, that's the green one, that's the blue one. Then I can also make this a bit nicer. I can say I want the lower y limits to start at 0, because there can be nothing below, like this. Then I can set the x limits to go from 0 to 1, because I already defined that they can't go outside of that through the bins here, right? From 0 to 1. Right, so that's already looking good. And now about the buttons, how we can actually make some buttons to go through the images. by the way, now already the zooming function should work, because here, right, the x.final limits observable. If I now zoom into this thing, then you can see that the histogram changes. And if I zoom into it further, it changes again. And I think, yeah, I can also do that like interactively, like this, which is kind of nice. At least I think so. Okay, so now let's get to the buttons. Right, we want to have two buttons below this image, one with like previous and one with next. And we'll just make a nested grid layout to hold them, which is like the easiest. If you have a sub container, then you just make a new grid layout. So a grid layout at row 2, column 1, that is right below, that will be below this plot on the left. So if I do this, now the same thing happened as before, right? Because there's nothing in this grid layout, the row is pretty big, but this will change now that I add the button to it. So I add a button at, I don't know why I started with next, but it doesn't matter. Okay, so one button next, that's here now. And the next one will be, yeah, that's the previous button. Okay. And then the idea was that whenever I click at the button, I just changed the index observable that I showed you in the beginning, right? Because the index controls all the rest of the stuff in the plot. So then I wrote the small like helper function, which is supposed to offset the index, and I passed like a button to it as well called B, because I want to change the label. So the idea is just I store what label it had, then I change that to loading, I modify the index observable, and I keep that in range from 1 to the length of the metadata, because otherwise I could fall off the edge and then index out of bounds. And then I also do what I showed before, right? I reset the limits on both axes, because those values will have changed. I guess I don't even need to do axis 2, because it's already handled by this function here. Right, I can actually, I think, remove that. Okay, so the offset index function, I do that now, and then now I assign that to happen whenever I click those buttons. So there's the clicks attribute, which just counts up whenever you click the button. So when you listen to that, like we don't actually need to use the number that comes out of this, but we can just call our function. And we have this async syntax because in Julia, like we don't want the whole thing to hang while it downloads a new picture, right? So that's supposed to happen in like a thread or like a task, more like. So now I assign that on the first button, this should happen, and here also the second one. And you can see on the first one, I offset by 1, so it goes up, and on the other one, I offset down. So, and now it should work. So when we press next, it loads the image, and there's the image. And the histogram changed and the image changed. I can zoom in, can look at those reds here. Oh, it has a lot of red, unsurprisingly. Right, and can go further, next image, and so on. And if we looked at, like, for example, we can look at on index, just to show you again what happens. So on index to I, let's show just I. We can just see that whenever we press a button, the index goes up. So I is 6, I is 5, I is 6. Now it loads an image again, I is 7, and so on. So yeah, that's how in not a lot of code you can specify a dynamic app that reacts to the data that you change. And yeah, I think you can go with your own creativity and think of things that you could do with this. And of course, these are all like interactive, like I can zoom around here if I want. Yeah, as I showed you before. Right, I think that's pretty much it. And we are also kind of out of time. So yeah, Simon, I'll ask you to come back. We can answer like last questions if there's there's more stuff.
Yeah. Thank you. That's a really cool app. That seems to be the main comments.
Yeah, that's yeah, thank you. What's my monospaced font? Oh, it's this Apple thing. It's SF Mono. Important questions first.
I think we missed some questions in the very beginning, but I'm not even sure if the context is right anymore, and if the people.
I was like in a tunnel. I didn't see anything. I didn't see any questions.
So I would suggest to just ask this question on Discord, Discourse, or Slack, preferably.
Yeah.
Cool.
Yeah, probably Discord. Yeah. Go to our Discourse, to the new one. I think everybody can just go there, right, Simon?
Yeah, there are already quite a few people that joined.
Yeah. Okay, cool. Yeah, just ask them there because I have to go to a birthday party and can't can't answer now. But I'll come back to those later.
Yeah.
And yeah, someone asked like the buttons don't seem to be from a specific toolkit. No, all hand coded by yours truly. It's an insane task of reinventing all standard GUI kit things. But yeah, I did that at least for some widgets. We'll have to see in the future if we can pull in some other like more established GUI kits, because like it's really insane to implement really good text handling, and I think if we don't have to, we don't want to.
Yeah. I think there's already some prototypes for GTK and Qt integration, but it's not very maintained. But maybe in the future, there could be a project to actually improve that by a lot.
Yeah. Right. Someone asked, does Maki have a way to visualize tabular data like VS Code display? Not really, but I mean, you can kind of abuse. I can quickly show that. You can abuse the grid layout. Yeah, I always like setting up grid layouts. You can do like this. Whoops, I'm trying to go too fast. Let's say like 5 rows, and then
I definitely also remember some discourse thread where someone tried that. I don't know if that ended up in a package or just in a script.
Yeah. I mean, I did stuff like that before, so so you can. I think this should work. Yeah, there's a table. So if you do now like resize to layout on that, that's actually what it's handy for, right? Because then, yeah, that's your table. And you could also do stuff like font is like I equals 1, and then it's like Maki here's bold, I think, and otherwise it's just Maki here's, I think. Should hopefully work. Yeah, now the first line is bold. I mean, font size is 30 or whatever. So yeah, you can. So if you have a plot and it has to have a it has to have a table next to it, you can definitely do it with like grid layouts. Okay.
Yeah. All right. I think we just terminate punctually.
Amazing.
Thanks for joining.
Okay, well, we needed less time because we started later, but that's fine.
Yeah.
Cool. Yeah, we'll be happy to see new people in the discourse and asking questions. Discord is the chat app. Discourse is the general Julia forum. Both are cool. Go to both.
Exactly.
All right.
Cool.
Yeah.
Thanks, everyone, and see you around at JuliaCon.
Yeah. All right. Have a great evening, everybody, or morning if you're on the other side of the earth, and so on. Cool.
See ya.
Bye.